All right, so this morning's lesson is review on solving quadratic equations by factoring, and we're also going to talk about x-intercepts, how solutions of quadratic equations are related to x-intercepts of parabolas. Okay. In grade 10, we learned to solve a quadratic equation by factoring. Factoring can be an efficient way to solve a quadratic equation. However, the factoring method only works for factorable quadratics. So not every quadratic is factorable. That's why we have the quadratic formula, okay? And also completing the square, if you like that. So your factoring flowchart from the last chapter will help us. And we're just going to practice ones that are factorable. Okay, so you can see it is the shortest method if you are good at factoring. Okay, for sure. So solve each quadratic equation by factoring. Note if the quadratic equation is factorable, the roots or solutions will be rational numbers, which are integers or positive or negative fractions. Okay, if it's factorable. All right, so if you notice, here's our quadratic equation. It's still got this format. Same as yesterday. So it would be ready for me to use the quadratic formula, but instead we're going to try to solve it by factoring. Okay, so you get your flowchart out. Always check for common factors first. Is there any common factors amongst the first three terms other than 1? No. Count the terms, there's 3. So then we're going to classify the trinomial that's on the left side. What type of trinomial is it? Simple. So a simple trinomial is a one-step. That means I should be able to do this. Okay, so I would have an x at the start of each factor, and then 2 numbers that multiply to 30, but also add to 11. 5 and 6. So 5 times 6 is 30, 5 plus 6 is 11. Okay, so what I've done, so just humor me for a minute here, is I've rewritten this as 3 terms adding to give me 0 to 2 different terms multiplying to give me 0. Okay, so x plus 5 multiplied by x plus 6 equals 0. Okay, so I've turned it into a times b equals 0. So think about any 2 numbers. If you multiply them together and get 0, what has to be true about one or both of them? One of them has to be 0. Okay, the only way to multiply 2 numbers together and get 0 is if one of them is 0 or both of them are 0. Agreed? Can you think of any other way to do it? Multiply 2 numbers together and get 0? No. Okay, so one of them has to be 0. All right, so that's what we've done. We've changed it from where it would be hard to guess what numbers would work to put in for x that would make this side also equal to 0 to where it's pretty easy to tell what numbers to put in for x would make it 0. Okay, so either this number that we don't know, this unknown number x plus 5 has to be a 0. So either x plus 5 has to be a 0, or this unknown number x plus 6 has to be 0. The only way for the number x plus 5 to be 0 would be if x were, nope, 0 plus 5 is 5, negative 5. You see that? If x were negative 5, in this bracket I'd have negative 5 plus 5, which is 0. Okay? If x were negative 5, this number would be 0, and this number would be positive 1. Negative 5 plus 6 is 1. 0 times 1 is 0. Okay, so negative 5 makes this equation true. And if you were to sub it in here, it would make it true as well. You get 0 on this side. Okay, everybody good? I've got one solution so far. Now I'm going to get this one. For x plus 6 to be 0, what would x have to be? Negative 6. Good. So subtract 6 on both sides. X equals negative 6. So here are my 2 solutions, negative 5 and negative 6. And you can see if you sub -5 in here to the beginning, I would get bracket -5 bracket squared plus 11 times -5 plus 30, and that gives me 0. Okay? Same thing if I were to sub -6 in there. Bracket -6 bracket squared plus 11 times -6 plus 30 equals 0. Okay, so those are the two solutions that make it true. And notice that in this case they're integers. We said they'll either be integers or positive or negative fractions. They'll be rational. All right, so similar idea, we're going to try factoring. So first step in our flowchart, is there any common factor among the terms containing x? No. 3 terms, what type of trinomial is it? Simple, which means one step. So I'm going to have an x at the start of each factor, and then I need 2 numbers that multiply to -20 and add to +1.
5 and -4.
Yes, good job. So x plus 5 and x minus 4. Okay? So now I've changed it from adding and subtracting to get 0 to 2 numbers multiplying together to get 0. So one or both have to be 0 for that to work. So either this number is 0 or this number is 0. And then that gives you 2 really easy grade 9 equations to solve to get x by itself. Okay, you can subtract 5 from both sides and get x equal to -5 as one of our solutions. And in this case, we would add 4 to both sides to get x by itself. And then x would equal 4. So those are our 2 solutions. Okay, C. Different. It doesn't have all the terms on one side and 0 on the other. So how can we add or subtract to make it look like that?
You have to bring either the 5x or 15.
Yes, so I'm going to subtract 5x on both sides. Also subtract 15 on both sides, which is going to give me x squared minus 2x minus 15 equals 0. So now it's got all the terms on one side and 0 on the other, which is what we want when we're solving a quadratic equation. Okay, so now we go to our factoring flowchart. Is there a common factor amongst all the terms? No. Count them. There's 3. What type of trinomial is it? Simple. Okay, so I'll give you time to finish that one. We already have. Want the 2 numbers that multiply to -15 and add to -2.
Here's the negative part.
Okay, so this one had an extra step because we had to bring everything to one side. Then we factored our simple trinomial. Now we're going to set each factor equal to 0 and solve for x. And we get our solutions to be x equals to -3 and x equal to +5. So you can see that solving by factoring is a lot shorter than using the quadratic formula, okay, and reducing radical roots like it is. If you're good at factoring. If factoring isn't your thing, you still have to know how to do it today, but maybe whenever you come across one in physics or something, you're going to choose to do it using the formula. Yep?
If you were to use the same equation and use the quadratic formula, would you still get the same?
Yeah, you would get the same answers, because what would happen is the number under the square root sign, you'd be able to, it would end up giving you like 25 or something when you square rooted it.
Okay.
Or like 20. So you'd be able to work with that number, then divide, and then finally get to these roots. Yes, you get the exact same answers. Okay? All right, so the next one. So check for common factors first. Is there common factors?
No.
Yes, there is. What's in common with both terms? 2x. Okay, so then you're going to 2x squared divided by 2x is x. Negative 6x divided by 2x is negative 3. Okay? Any ideas what's going to happen next? Anyone? This one I think we all would do x minus 3 equals 0. What are we going to do about this? So 2x equals 0, Jeff? I agree. That's not what you're going to say. You said divide.
Oh, yeah, no. But that was my second guess.
But you are going to divide, right? You're going to divide by 2. You are going to, right? But this would be what you would show first. Okay? So how do I get x by itself in this one? It's not adding or subtracting like it is over here. Over here, I would add 3 to both sides and get x equals 3. Here I would divide both sides by 2. And 0 divided by 2 is 0. Does it make sense to have the solution be x equals 0? Try it out here first. So 2 times 0 is 0. 0 times negative 3. Because if x were 0, this bracket would be negative 3. So 2 times 0 is 0, times negative 3 is still 0. And what about if you put it in up here? I have 2 times 0 squared minus 6 times 0. Would that give me 0? Yes. Okay. So you can always check your answers by subbing them back into the original equation, making sure they work. Okay. All right. Here's another one where we need to get all of our terms on one side first. Subtract 5x. And there's no x ending term on this side. Does everyone agree with that? On the left, there's no term that has an x ending. So we know we want to have it go in the middle. So I'm going to have 2x squared minus 5x minus 3 equals 0. Okay, so now I've got it in this format. Ax squared plus bx plus c equals 0, which is what you want a quadratic equation to look like. Okay? Now, a lot of people, if you had a choice, if you didn't say solve by factoring and you had a choice, you would choose to use the quadratic formula here, because what type of factoring do you have to do here? Complex trinomial. Common factors? No. Count the terms. 3. What type of trinomial is it? There's not a 1 in front, there's a 2, so it's a complex trinomial. Which are probably the hardest ones to factor? Thank you very much. So, remembering back to how you factor a complex trinomial, the first step is you multiply the first term by the last term. And you write that product off to the side, so that's negative 6x squared. And then we want two terms that multiply to negative 6x squared, but add to negative 5x. So we'll start off, the bigger one has to be negative, so we'll start off with 1x and negative 6x, and that does add up to negative 5x. Yes? So then we write out the first term, the 2x squared, and ask ourselves, what has more in common with 2x squared, 1x or negative 6x? And knowing that 2 goes into 6, I choose to put the negative 6x next. Okay? And then the positive 1x, and then the minus 3, and then the equals 0. So again, the second step in a complex trinomial is to decompose, that's why it's called decomposition, break negative 5x up into negative 6x plus 1x. So that's all we did there. Those two lines are equal. We just chose to do that so that now we can factor by grouping. So if you just look at the first two terms, we want to look at what's in common with 2x squared and negative 6x. Greatest common factor, 2x. And then mentally divide 2x squared divided by 2x is x. Negative 6x divided by 2x is negative 3. Sign that comes next goes next. It's a plus. What's in common with 1x and negative 3? Just 1. So positive 1x divided by positive 1 is x. Negative 3 divided by positive 1, negative 3. So if you do everything right, what happens is you end up getting a common binomial. Okay, so once you've grouped, x minus 3 becomes your common factor, even though it's a binomial. It's common to both of these big chunks, okay? So the x minus 3 is my common binomial. And if you divide each big chunk by x minus 3, you get whatever's left over. The leftovers form the other factor. So it took, the decomposition is a 3-step process, 3 steps to get it factored. Once you have it factored, you want to set each factor equal to 0 and solve for x. Set each factor equal to 0 and solve for x. Okay, so here I would just add 3 to both sides. This is the easy one to solve. Here I would first have to subtract 1 on both sides. And then divide both sides by 2. So here are my two solutions, x equals 3 and x equals negative 1/2. Okay. Any questions about this one? Factoring a complex trinomial? Coming back? A bit again? All right, recall from previous grades that to solve for the x-intercepts of a relationship, you set y equal to 0 and solve for x. Okay? X-intercepts, again, I did a little review from grade 10 up here already for charts anyways. X-intercepts are the places that the graph touches the x-axis. Okay? This is the equation of a parabola that's in intercept form. It's got the step number out front. Okay? And then x minus the first x-intercept, and it multiplied by x minus the second intercept, x-intercept. Okay? If there is 2. A lot of parabolas have 2 x-intercepts. Okay. Maybe we should do some Desmos with that, just to give you a visual and a review. Some of you may not have done very much intercept form in grade 10. So we'll start off with some easier ones, and then so if I want my step number to be just a 1, which I wouldn't even need to show, and my intercepts to be, say, I want my intercepts to be 3 and 5, then it would be x minus 3 times x minus 5. And you can see, here's my equation. My step number's a 1. My intercepts are positive 3 and positive 5, and that's because there's a minus in the formula, okay? And my step number's a 1, so I should be going over 1. Now this scale's weird. 2 squares is 1, but over 1, up 1, over 1, up 1, 2, 3. It fits. Okay? What happens if I change this 1 to a 2, do you think? Step pattern changes, so it's going to be stretched, vertically stretched. Okay, so it's got the same x-intercept still because I didn't change the 3 and the 5 at all. Okay, but it's steeper. What do you think is going to happen if I change the 2 to a, I don't know what that means. What do you think if I change it to a negative 2? It's going to turn upside down? Yep. Okay. Okay, what if I want negative x-intercepts? Say I want my x-intercepts to be negative 3 and negative 5. How would I change the equation? In the brackets, so x minus negative 3 is the same as x plus 3, and x minus negative 5 is the same as x plus 5. And now my intercepts are at negative 3 and negative 5. But when I look at my equation, I see plus 3 and plus 5. And that's because of the negative in the formula. Okay, so for you to see x plus 3 and x plus 5, what you're actually seeing is x minus negative 3, x minus negative 5. But you don't write x minus negative 3, you simplify it so it becomes x plus 3. Okay? How many people saw that last year? Grade 10. Okay? All right, so we'll keep trying to go back to that. I'll do Desmos at the beginning of the next lesson as well. And hopefully we'll remember back to intercept form. All right, determine. Okay, so recall from previous grades that to solve the x-intercepts of a relationship, you set y equal to 0 and solve for x. That's just a general rule. So whenever you want to find x-intercepts, you set y to 0 and solve for x. Okay, that's a general rule. When you're trying to find x-intercepts, you set y equal to 0 and solve for x. Okay? Applying solving quadratic equations to finding x-intercepts is important for grade 12. That's why we're doing it. Okay? Determine the x-intercepts of each quadratic function or parabola. Okay, we want the x-intercepts. So I did a Desmos, or I did a handicap graph so you know what they should be, but we've got to be able to figure them out ourselves. You're not always going to get the answer on the side, right? So we said set y equal to 0. Solve for x. So if I set y equal to 0, I have this. But most of us prefer to have the x on the left, so I can just switch sides since it's an equation. Both sides are equal to 0. And I can use my factoring flowchart to see if this is solvable by factoring. So is there a common factor amongst all the terms other than 1? No. There's 3 terms. If it were factorable, what type of trinomial would it be? Simple? So simple trinomial, I would need two numbers that multiply to 8 and add to 6. 2 and 4. So positive 2 and positive 4 multiply to 8 and add to 6. But those are my x-intercepts. I have to set each of these factors equal to 0 and solve for x. And those will be my x-intercepts. So I get that x equals -2 and x equals -4. So there's one x-intercept, that's -4. And here's my other one, that's -2. We might as well go back to grade 10 here. I could call this one my first, I could call -4 R1 and -2 R2. If I want to rewrite this parabola, so right now this is standard form. If I want to rewrite my parabola in intercept form, it follows this pattern. So let's see what it would look like in intercept form. So the A stays the same. A was 1 here, the step number. So it's still going to be a 1 here. Do I have to write a 1 if it's a 1? No. Okay, I can if I want to, but I don't need to. X minus R1 is -4. X minus -2. X minus -4 is the same as x plus 4. X minus -2 is the same as x plus 2. Okay, so that's rewritten in, this is called intercept form, which is the one on the chart paper up there. So the step numbers out front, the two x-intercepts are in the brackets. Okay, and you can see that the intercepts are -4 and -2, even though you see +4 and +2 in the bracket. Okay, next one. Y equals x squared plus x minus 6. So the first step is set y equal to 0 and solve for x. I'm going to switch sides. So then I'm going to see if it's factorable. So that follows my flow chart. Is there a common factor amongst all three terms other than 1? No. Count the terms. 3. If it were factorable, what type of trinomial would it be? Simple, which would mean there was two numbers that multiplied to -6 and added to +1. So the bigger one would have to be positive. They multiply to a negative and add to a positive. So we could have -1 and +6. That does not add up to +1. We could have -2 and +3. That does add up to +1. So those would be my numbers. So then I'm almost there now. I just set each factor equal to 0 and solve for x. Oops. So we get x equal to 2. And x equal to -3. Let's see if that's what our graph says. X equal to 2 and x equal to -3. Yes? If we want to write it in intercept form, this is the pattern we want to follow. So this is standard form of a parabola. This is called intercept form of a parabola. So our A is the same again, it's a 1, which I don't need to show. X minus -3, x minus 2. Okay? And then when you subtract a negative, you add. So that's what the parabola would look like in intercept form. Okay? So for C, notice how my intercepts aren't on corners. Notice that? So what's going to happen is probably not going to end up being factorable. Okay, but we're going to use the same approach where we set y equals to 0 and solve for x. Okay, so 0 equals -x squared minus 2x plus 15. I'm sorry, plus 5, yeah, 15 would have worked. Plus 5. Thanks, guys. All right, since we're equal to 0, I like to have a positive number in front of my x squared when I'm deciding whether something can be factored or not. So rather than just switching sides, I'm going to switch all the signs. So I'm going to add x squared to both sides, add 2x to both sides, and subtract 5 from both sides, so that I end up with x squared plus 2x minus 5 equals 0. Okay, so still going to have the same solutions, but I have a positive number in front of my x squared. So if I didn't have the graph and I didn't know that it's probably not going to be able to be factored, I would first check for common factors. There isn't any other than 1. 3 terms. So it's set up like a simple trinomial, but in order for it to be a simple trinomial, there need to be 2 numbers that multiply to -5 and add to +2. So 5 is easy because only 1 and 5 multiply to 5. And we'd need 1 positive, 1 negative, and the bigger one to be positive. So 5 and -1 are our only choices, and that does not add up to +2. Is everybody good with that? So it's not factorable. So if it's not factorable, you can either use completing the square or the quadratic formula to find the roots. Thank you very much. So what would you like to do? Complete the square or use the quadratic formula?
Alright, quadratic formula it is.
Quadratic formula it is. Okay, so A is 1, B is 2, C is -5. Okay, so then just make sure you substitute your numbers into the right spot. Everybody was doing well with that yesterday. I didn't see a lot of numbers in the wrong spots, which was really good. So write out the formula, sub in, make sure your numbers are in the right spots. Get the number under the square root sign. All right, so just new for grade 11. What would I do next?
Reduce it.
Yes, see if root 24 can be reduced.
4 times 6.
4 times 6, good. So that's going to be the square root of 4 times 6, good. Over 2. So that's going to become 2 root 6. Because the square root of 4 is 2. And then I still have to see if I can reduce by looking at these numbers and seeing if they have a factor in common. 2. Agreed? So I'm going to factor 2 out of the numerator. So 2. And then divide each term in the numerator by 2. So that's going to be -1 plus or minus root 6 over 2. And then 2 divided by 2 is 1. The 2's divide out. So I'm just left with x equals -1 plus or minus root 6. So those are my two x-intercepts. They look weird, but that's what they are. How would I know which one's which? Remember, there's 2 here. There's -1 plus root 6 and -1 minus root 6. How do I know on my graph which one's which?
Whatever your answer is, the sign will be opposite. So if you get a positive one, it would be negative. Or
These are the actual x-intercepts. We're not, I know what you mean. If it was an intercept form, yes, but these are the actual ones we solved for them. If you look back at this one, 2 and -3 were the x-intercepts. We didn't have to, we solved for them.
okay, no, that's the question of having confusion.
So, if you're not sure, okay, like this one's going to be positive and this one's going to be negative, and I can see that this is 2 negative, so I know this one's going to be -1 minus root 6. But if I wasn't sure, I could find decimal approximations, right? I could do -1 plus the square root of 6 equals, and it gives me 1.449. Okay, so I know that's going to be that one. Then -1 plus root 6. And then -1 minus root 6 gives me approximately -3.449, which looks like that one. Okay? And we'll see how to put this one in intercept form. That's our next lesson. Okay? When you get a harder intercept. That's what we're doing in our next lesson. Oh, good. Okay. We're going to stop recording.